We're dividing.
11-2.
Yes, we're still in 11-2. If you can find it in your weird old packet of notes that, I messed up. So, okay. So yesterday we multiplied fractions, right? And the big thing was we had to do any factoring we could. We had to cancel any factors we could. And then we just multiplied straight across. So that was the top half of the notes. The bottom half is specifically about division. Do you remember how to divide fractions?
No.
Flat out no, nothing other than that?
No.
Okay. So officially, the phrase we use is multiply by the reciprocal.
I've heard that word, but I don't remember it.
Okay. So officially, I'll say multiply by the reciprocal. However, your middle school teachers may have used the phrase keep, change, flip.
There you go,
Yeah.
right there.
That's
Okay. So those are the two phrases that I'm going to refer to. Okay. So officially, to be a good math teacher, I need to use the phrase and use the right lingo of multiply by the reciprocal. However, you will also then often hear me follow it up with keep, change, flip. And obviously I'm going to talk about what those mean today, right? Although I definitely saw light bulbs happen when I said keep, change, flip.
Yes.
You got a little bit better each step of the way, right? Okay, so when dividing fractions, the first thing you want to do is your keep, change, flip. Okay? Or in other words, multiply by the reciprocal. So when we say multiply by the reciprocal, we're going to keep the first fraction as is. We're going to change division to multiplication. And we're going to flip the second fraction. Which, what it means to take the reciprocal of a fraction is to flip the fraction. So thus we are multiplying by the reciprocal. So, let's start there. On this first one, we're going to keep. So I'm going to keep x over x plus y. Just keep that first fraction. Then I'm going to change. Change division to multiplication. And then I'm going to flip. So now it becomes
X plus Y.
x plus y over xy. So that is keeping the first fraction and then multiplying by the reciprocal. Now, this is where we'll talk about factoring and canceling. And this isn't really so much a factoring type of problem as it is more of just a canceling type problem. Do you see any thoughts about items that might cancel?
X plus Y.
An x plus y on top cancels with an x plus y on bottom. I can agree with that. Have any other thoughts of anything else that might cancel? Okay. Well, the only thing left on top is an
X.
x. On bottom over here, we have x times y.
Oh, well, I guess you can cancel.
Right. If this was an x plus y, no, we can't cancel just the x or just the y. But if it's x times y, we can cancel just one of them. And so we can cancel the x on top, can cancel with the x on bottom. Well, so what remains for our final answer?
Y.
And where is that y?
On the bottom.
In the denominator. And what remains on top? If everything has canceled, then it's a 1 by default. So 1 over y. Okay. Got some basics in there, right? Okay, let's look at the next problem. We have fraction divided by fraction. I'm not even going to bother reading it all out. You can see it. What is step 1? Keep.
K plus 8. 6.
So keeping 4k plus 8
Oops.
over 6k minus 10.
I wrote over that 8.
Huh?
So I just wrote an 8 and it looks really good.
Oh well. Okay, what do I do after I keep?
You change it to multiplication.
Division becomes multiplication. So we change. Then what?
And you flip over the 9 will become 9k minus 15 over k2 plus 6k.
For some reason I keep wanting to write x instead of k. Okay, so keep, change, flip. We're multiplying by the reciprocal. As soon as you're ready to multiply, it's all about the factoring.
K squared, that whole thing goes into 2 parentheses.
Okay? Kylie, starting on the bottom right. K squared plus 6k plus 8 factors into 2 parentheses. K squared breaks into k and k. We need numbers that multiply to be 8 and add to be 6. What can multiply to be 8 and add to be 6?
2.
2 and 4. So 2 and 4 goes in those parentheses. Positives or negatives? Positive. Okay, now we got to backtrack and check factoring on all the other pieces. 4k plus 8 is probably the next easiest.
Yeah.
Yeah.
What do you know about 4k and 8?
These here for 4.
Can they divide by 4? So if we factor out a 4, which means I'm going to put the 4 out front. 4k divided by 4 leaves me with
Okay.
k plus 8 divided by 4 leaves me with
2.
2. Okay. I don't know, pick one of the others to look at.
K 6k minus 2.
Okay, what about 6k minus 10?
2.
Can they divide by 2? So if we put that 2 out front, 6 divided by 2,
3.
3k, minus 10 divided by 2, minus 5. Okay, one last one. 9k minus 15.
3.
9 and 15 can divide by 3. So 3 out front. 9k divided by 3 is 3k. Minus 15 divided by 3, minus 5. Okay. Well, hopefully, that was a lot of factoring. Hopefully something good came out of this, right?
Yeah.
Otherwise, wow, why did we do all that factoring, right? Okay, you see anything?
K plus 2.
Okay, k plus 2 is gone.
3k minus 5.
3k minus 5 is gone.
I think that was it. I don't know.
I see one other thing. It's not quite as obvious, but there is one other thing.
3. Oh yeah, the 4s can go together.
Well, not exactly.
No, 'cause they're
This 4 that's part of k plus 4 is untouchable because it's part of k plus 4 that has to have another k plus 4. However, I do want to do something with this 4 up here. The only other thing left in the denominator is 2. What do you know about 4 and 2?
They can both divide by 2.
They can both divide by 2. So 2 divided by 2 is going to be gone, and it's just a 1, right? Or it just cancels. On top, 4 divided by 2 becomes 2. Okay, now I'm happy with the canceling. Started to say counseling. Canceling. Okay, final answer.
2 times 3 over k plus 4.
There's a 2 and a 3 on top, so 2 times 3 over k plus 4. What is 2 times 3?
6.
6 over k plus 4 is what you would want to put in for your answer. Gonna make you use those factoring brains.
Yeah.
Trying to grow those factoring brains big and strong. Making you work at them. Okay. Ready for the next one?
Yeah.
What are your thoughts to start us off with?
Keep, change, flip.
Okay. So multiply by the reciprocal, keep, change, flip. So we're going to keep z squared minus 2z plus 1 over z squared plus 2. We're going to change
It's multiplication.
division to multiplication and
Flip 0, z minus 1.
we're going to flip z minus 1. What is z minus 1 as a fraction already?
Z minus 1 over 1.
This is z minus 1 over 1, if you need that visual. So then when I flip it, it becomes 1 over z minus 1. In a problem like this, I tend to use the line through my z, so I don't get my z's and 2's confused.
Yeah.
It's either that or I also put the little loop in the 2. Anything to distinguish between the two, otherwise it becomes a very confusing problem. Okay, factor away.
Okay. Z squared.
Okay, so z squared minus 2z plus 1, set to go in parentheses. Z squared, z and z. Okay, think hard. What multiplies to be 1?
0.
1 and 1. How do we make those 1s multiply to be positive 1 and add to be negative 2?
And 1 is
Minus 1.
How about both of them are negative or minus? Because if it multiplies to be positive, they have to be the same sign. And in order to get them to add to be negative 2, they both have to be negative.
okay.
Okay? Okay. What else?
Z squared plus also z minus 1 can cancel. Wait, no. Yes. No.
It will in a moment. So, okay, if we go to this other fraction, 1 is just 1 on top. That's not changing. Z minus 1 is just going to stay z minus 1 for the brief moment. I do agree we'll cancel it in the next step. Z squared plus 2.
Yeah, that also goes into parentheses. 7.
Almost, but not quite. Here's the deal. If it was z squared minus a perfect square, so like z squared minus 4, z squared minus 9, z squared minus 25, then we'd talk 2 parentheses. Since it's z squared plus a number, it actually can't factor. Anytime you have a variable squared plus a number, it's called an irreducible factor. It does not factor. So, what cancels?
Z minus 1.
Z minus 1.
1z minus 1 on bottom cancels with
Z minus 1.
1z minus 1 on top. Not both. Anything else cancel? Nope. Last time there's a lot of canceling. This time, just a little. So what's my answer?
Minus 1 over Z squared plus 2.
Z minus 1 over z squared plus 2. And remember on top, z minus 1 times 1 is going to be z minus 1.
Yeah.
Okay. One last problem.
Okay. I can do it.
On this one last problem. Now, this one last problem looks different. It's what we call a complex fraction. Okay? We call it a complex fraction because what it is it's a fraction divided by a fraction. But notice, we're dividing fractions, aren't we? So this is a fraction divided by a fraction. So what I'm going to suggest we do is I'm going to write it out as division, and then we'll do some changing. So if I write out kind of like horizontally how we're used to it, the top fraction is 1 over q plus 4. And then it's divided by the fraction below it, which is 2q squared over 2q plus 8. That is my suggestion for how you begin a complex fraction problem. Is to take the two fractions and write them out side by side. Top divided by bottom.
Okay.
And now that I have top divided by bottom, I need to
Change.
keep, change, flip. So I'm going to keep
1 over q plus 4.
1 over q plus 4. I'm going to change
Into a multiplication.
division and multiplication. And I'm going to
2q plus 8.
2q plus 8 over
TQ.
2q squared. Why is that such a tongue twister?
I don't know.
I'm struggling to say that. Okay, so we are multiplying by the reciprocal. What would you like to factor?
2q plus 8.
Okay, 2q plus 8. What about 2q plus 8?
2.
They can both divide by 2. 2q divided by 2 is
Q.
q, plus 8 divided by 2? 4. Okay. Two q squared is just 2q squared. If there's a 2 someplace else or a q someplace else to cancel, we can talk about canceling a 2 or a q, but it's just 2q squared. There's nothing to factor there. 1 is 1. And what about q plus 4?
Q plus 7.
Q plus 4?
Yeah.
The only thing you can do there is a GCF, and it's just 1 q, so there's no GCF either. What would you guys like to cancel?
Q plus 4.
Okay, get the obvious out of the way. Q plus 4 cancels with Q plus 4.
Can't put 1, 2.
Here's the deal. Up top we have a single 2, yes?
That's what I meant.
On bottom we have 2
Q.
times Q squared. If that was added to something, it'd be a no-go.
Oh.
Because it's 2 times Q squared, because it's 2 times something else, you can cancel it as a factor. So the 2 will cancel. Okay? Final answer.
1 over q squared.
I agree with her. 1 over q squared. Okay. Get working on that homework. Lesson 11.2 in Math Excel.